This is a fun assessment that gives us an idea of some of the challenges of doing complex molecule synthesis. And so let's imagine that we wanted to make this molecule here with the alkyne in the center, and we want to attach it to two different aromatic rings on either side. We might have thought about starting this reaction using acetylene itself in the Sonogashira reaction. But how would we ensure that we add one aromatic ring to one side and the other to the other? How do we avoid adding two of the same, right? Could we just add the same R group to both sides? Could we add R prime to both sides? Both of these could happen when our goal is to put one alkyl group or aryl group on one side and the other on the other. And so if our goal is to do this, we can't really start with this because there's nothing to discriminate between either side of acetylene. Enter this molecule here, this TMS acetylene, where the TMS is a trimethylsilyl group. Let's go ahead and draw out what that is. It's this molecule here. Well, this silyl group, this trimethylsilyl group, is going to act as sort of a protecting group. It's going to ensure that the only reaction we do at first is going to be on this side of the molecule. And so we could react this with, let's pick the aryl halide on the left. So this bromo-nitro compound. Our typical conditions of the Sonogashira would be copper iodide, palladium tetrakis, and typically some amine base to help make the copper acetylene. This is going to result in a new bond forming between this carbon and this carbon only, and we let one equivalent react with one equivalent to completion, so that the product of this first step would be this. Once we're here, we're now ready to attach the aryl iodide that's shown in orange. But to do that, we have to remove the trimethylsilyl group. And so we can do this using a fluoride source like potassium fluoride in water. Not so worried about the mechanism of that reaction, but what that's going to reveal is another terminal, or a different terminal alkyne. Now we should be able to react this one with our other aryl iodide, allowing us to get selectively the product on screen. And so we'll react this with the iodide shown. Make sure I decorate it correctly. We'll use our same conditions. So copper iodide, palladium tetrakis, and our amine base. Because this is the only CH bond left, and this is the only electrophile for the Sonogashira, that's going to be the bond that forms next. And so we're able to make selectively this alkyne with a different alkyl group on either side. Why we could do that is because by starting with TMS acetylene, we had an available CH bond, and the other one was protected or masked, only to be revealed later by this deprotection step. I said at the beginning this would be fun. It was a fun assessment. I hope you had fun. I know I did.